Welcome our students. Today we are going to see about the dispersion of white light through prism. Here we are going to take a glass prism. Through the glass prism, if you incident one of that white light ray, then that white light ray enter through a prism from one of the refracting phase. After the entering in the prism, that white light ray is refracted but not moves as a single refracted ray. That we have here 7 number of refracted rays. Then that 7 refracted rays are emerged as a 7 color rays, because white light has 7 colors. So now we are going to take a prism diagram. Actually, in what shape we are mentioning means triangular shape we are mentioning, that is glass prism. There in our glass prism 2 triangular faces and 3 rectangular faces. And also we have, this is one of the refracting phase, phase 1, refracting phase 1, second refracting phase, and this is called as a base of the prism. The angle between the first refracting phase and the second refracting phase is called as a angle of the prism. What is the angle of the prism? Angle between the 2 refracting phase is called as a angle of the prism. Okay. From a source of white light, we are going to take a single ray of white light that is going to incident on the one of the refracting phase. This is a white light ray. Single white light ray we are going to take. Before entering the first refracting phase, it is moved as a single ray. But after that entering, it is moving from air medium to glass medium. We know already all the colors in our vacuum moves in a same velocity. So that's why our vacuum medium or air medium is taken as a non-dispersed medium. No dispersion takes place because velocities are same. But that white light ray which contains the 7 colors moves in the same velocity in vacuum, and it entering the prism, it is in a glass medium. Other than that vacuum or air, rays are moving means their velocities are depends upon that wavelength. We know that the wavelength of that white light is ranged from 400 nanometer to 700 nanometer. Where white light wavelength ranged from 400 nanometer to that 700 nanometer. That is from violet to red. That is violet to red. The lowest wavelength which one we have means violet. Highest wavelength is red. That's why in our glass medium, red travels in the highest velocity, but violet travels least velocity. Due to that, velocities are different for the different colors. rays which are moves in our glass medium deviated in a different directions. That's why violet deviated like that, and red may be deviated like in between that other colors. Totally how many colors? 7 colors. That final, that is the most deviated ray, this is violet. Then least deviated ray, red. In between that other colors, other 5 colors. Seven. We represented for shortly for recalling VIBGR. So violet, indigo, blue, green, yellow, orange and red. These are the colors in our single white light ray. 7 colors are in that single white light ray that can be splitted when single white light ray enters in our glass prism. From one phase we are entering, that is make the instinct that one white light ray, but other side we are producing a 7 separated ray, each one having a certain colors. So that's why the 7 colors are shortly named as VIBGR. So what phenomena we done here means dispersion phenomena we can done. What is happening in our dispersion means we split their individual colors into separate one. That's why we have the definition for the dispersion. Dispersion is nothing but splitting of white light, that is any composite light we can take, into its colors, constituent colors. What are the colors inside that single white light ray means 7 colors, that is shortly named as VIBGR. And the band of these colors is called as a spectrum. Then the band of these colors is called spectrum. Spectrum of white light. Spectrum of white light. In our spectrum of white light, we have here 7 colors. The lowest wavelength is for violet, and the highest wavelength is for red. So this is the reason, that is the velocity is different for the different color in other than that air or vacuum. That's why if you pass that single white light ray through the glass medium, there we have a dispersion. Which one is most deviated? Violet is most deviated. Which one is the least deviated? Red is the least deviated. That's why from lower to that higher we are mentioning violet to red. Violet to red we can take. This is a phenomenon called as a dispersion. Deviation is different for that different colors. Then we are going to see about the dispersive power of our glass prism. Dispersive power of our glass prism. The same glass prism is going to taken, and through that we are using that single white light ray at one of that refracting phase. But if it is enters in that glass prism, that single ray is split into 7 colors. This is taken as a violet ray. This is taken as a red. If it is not deviated inside a prism, that ray is moving in a direct in that incident ray directions. From its that 7 colors are deviated, each one having a different angle of deviation. Violet has an angle of deviation that may be expressed as del V. Red has an angle of deviation that may be expressed as del R. That is a greater angle of deviation for that violet, smaller angle of deviation for that red. Anyhow, other colors are smaller angle of deviation as compared to that violet, and greater angle of deviation as compared to that angle of deviation of that red. That we are going to calculate. For that purpose, refractive index formula based on that Snell's law we are going to tackle. N is equal to, that is refractive index of that glass prism is equal to sine of angle of the prism A plus angle of minimum deviation divided by 2, then divided by sine of angle of the prism divided by 2. Now, for finding the dispersive power, we are going to take a small angled prism. If you take a small angled prism, then the angle of minimum deviation is also small. What range we use for that small angled prism, angle of the prism means, that is 10 degree or maybe less than 10 degree. If you have the angle of the prism means, then the prism is called as a small angled prism. If angle of the prism itself 10 degree, if you take and means angle of minimum deviation also less than that 10 degree. So our trigonometry function we are going to see, if theta is too small, sin theta can be taken as a theta. That is we are going to apply. If d is equal to del, then you substitute in our equation, that is n is equal to sine of a plus del divided by 2 divided by sine of a by 2. So if you change that capital D as a del small value, then according to our function sin theta can be taken as a theta. So from this n is equal to, instead of sine of a plus del by 2 can be taken as a plus del by 2 only, as well as for that sine of a by 2 also only a by 2. So for that a plus del divided by 2, then divided by a by 2. There we have a 2 divided by 2 cancel. So then refractive index of the prism n is equal to a plus del divided by a. Now we are rearranging to find that angle of deviation. Na equal to a plus del. Then del is equal to Na minus a. So del is equal to n minus 1 into a. This is the angle of deviation formula. Del is equal to n minus 1 into a. So So the angle of deviation depends upon that what are the factors means angle of the prism and the refractive index of the prism. If white light is entered in our glass prism, there that white light is split into 7 colors. Which one is most deviated? Violet is most deviated. Which one is least? Red. So deviation is different for the different colors. So for red, angle of deviation del R equal to NR, refractive index of that prism for red minus 1 into A. Similarly for that violet, del V is equal to N suffix V minus 1 into A. We know that del V is greater than del R. So that's why we have a difference of angle of deviation for red to that violet. We can take an angular dispersion. Angular dispersion. Angular dispersion is nothing but separation of that deviation of that two extreme color deviation. Which are that two extreme color deviation? Red and violet. That is called as a angular dispersion. Angle between the separation of two extreme colors. Which one is two extreme colors means violet and red alone. So that's why we are going to express for the angular dispersion del V minus del R. Then for del V we are going to substitute NV minus 1 into A, then minus NR minus 1 into A. From this NV into A minus A, then minus NR minus NR into A, then minus into minus plus A. Minus A and plus A are cancelled. So del V minus del R equal to NV into A minus NR into A. We have the common angle of the prism. So that's why NV minus NR into A. So del V minus del R is equal to refractive index of that violet minus refractive index of that red into angle of the prism. So that's why angular dispersion depends upon what are the factors based on our formula. Material of the prism as well as the angle of the prism. The angular dispersion depends upon material of the prism, nature of the material of the prism and angle of the prism. Why we are saying nature of the material of the prism means if densities differ, refractive index also differs. As well as for violet has certain refractive index, that value is greater as compared to the other colors, and red also having a refractive index, that value is a least value. So from that expression del V minus del R is equal to refractive index of the violet minus refractive index of that red into angle of the prism. So that is called as a angular dispersion. In that 7 colors, most deviated is violet. least deviated red. Which one has mean deviation? The center color, which is in the middle, that color has a mean deviation, which may be in the middle means either yellow or green, either yellow or a green. So that mean deviation can be taken as a formula del is equal to n minus 1 into A. From our formula, del is equal to refractive index of that mean wavelength color minus 1 into angle of the prism. Now we are going to see that dispersive power. What is dispersive power? Ability of the glass prism to make a dispersion of given white light is called as a dispersive power. That is the ability of the prism to make a dispersion for that given white light. That is called as a dispersive power, and we have a formula also for that dispersive that we are going to see. Next we will see the formula for that dispersive power. That symbol is omega. That is the ratio of angular dispersion to the mean deviation. Dispersive power is nothing but a ratio of angular dispersion to the mean deviation. So dispersive power formula is angular dispersion divided by mean deviation. Angular dispersion formula is del V minus del R equal to NV minus NR into A. Mean deviation is del is equal to N minus 1 into A. So in our formula omega, we are going to substitute del V minus del R divided by del, that can be equal to NV minus NR into A divided by N minus 1 into A. NV is the refractive index of that violet color, NR is the refractive index of that red color, N is nothing but a mean refractive index, that is either yellow or green, mean deviation colors. So that is taken. From our formula, A and A are cancelled, and from our formula we can take an omega is equal to del V minus del R divided by del equal to NV minus NR divided by N minus 1. From our formula, the dispersive power depends upon the refractive indexes of these colors, that is violet, red and mean refractive index. So that's why we are saying dispersive power depends upon nature of material of the prism. Nature of the material of the prism does not depend upon the angle of the prism. So material to material for a given white light ray, dispersive power is different. Dispersive power is different because dispersive power depends upon that nature of the material of the prism, does not depends upon that angle of the prism. Already we know that angular dispersion depends upon what are the factors. Angular dispersion depends upon angle of the prism and nature of the material of the prism. But our dispersive power does not depend upon that angle of the prism. Okay. Next, what is the unit of the dispersive power? So we have the ratios of that refractive indices only. So that's why unit of dispersive power is no unit, and we given the value of dispersive power only numerical value. That's why no unit for the dispersive power. We have learned about dispersion of white light through a glass prism. What is the dispersion of the white light through a glass prism means? Splitting of white light into its colors is nothing but a dispersion of the white light. Then the arrangement of band of these 7 colors is called as a spectrum of our white light. Spectrum of our white light. Then we have the angular dispersion as well as the dispersive power. What definition for our angular dispersion means? Difference of deviation between the two extreme colors in our spectrum. That is called as a difference of deviation between the two extreme colors is known as the angular dispersion. Then what is the definition for dispersive power? Dispersive power is defined as the ratio of angular dispersion to mean deviation. But in general, that is the ability of the prism to make a dispersion. Dispersive power is nothing but ability of the prism to make a dispersion. And dispersive power has no unit because same type of physical quantities we are dividing. And another thing we have in our problem, if they are given deviation of the violet and deviation of the red, we can calculate that mean deviation. How we can calculate the mean deviation means it is del is equal to del V plus del R divided by 2. If we have is a deviation of the violet and deviation of the red, mean deviation we can calculate. In the same manner, suppose they are given refractive index of the violet and refractive index of the red is given. What is the mean color refractive index means? That is n is equal to refractive index of the violet plus refractive index of the red divided by 2. From this we can calculate. If you know these two factors, we will find that mean deviation, that is del V and del R. If you know they are given, we can calculate this. Then from these values we will find the dispersive power. Suppose they are given the del V and del R alone. Otherwise, another type of problem we have for finding that dispersive power. Only they are given the refractive index of that violet and red. Violet and red. So how we can calculate the dispersive power means we have a formula NV minus NR divided by N minus 1. Without giving that mean refractive index, how we can calculate? We don't need that. From our expression N is equal to NV plus NR divided by 2, we will get that mean refractive index. So you can substitute that values to find that dispersive power. Okay.